In this video, we will understand important terms related to spherical mirrors and the image formation by the spherical mirrors at several positions. Let's understand what spherical mirrors are. Spherical mirrors are segments of a spherical glass ball. They are cut in the fashion as shown here. Now the arc obtained can be polished in one of the two ways. Number 1. If the inner portion is polished, the mirror so obtained is called convex. Number 2. If the outer bulge is polished, the mirror is called concave. Next term is center of curvature, which is denoted by C. It is the geometric center of the sphere from where the mirrors are obtained. The second term is radius of curvature, denoted by R. It is the radius of the spherical ball. The next term is the pole, denoted by P, which is the center of the polished mirror. Next term is aperture, which is defined as the chord AB that is formed by joining the endpoints of a spherical surface. Next, we define a straight line that passes through pole and center of curvature called as principal axis. Now, if we pass number of rays parallel to the principal axis, all these rays will meet at a specific point on the principal axis. This particular point is known as focus and is denoted by F. The distance between pole and focus is called focal length and is denoted by small f. Since the distance between pole and center of curvature is called radius of curvature, which is denoted by R, there is a relationship between radius of curvature and focal length, which is R is twice of f. We will derive this relation in some other video. For the time being, just keep this relation in mind. These terms will be same for convex mirror, except for the fact that concave mirror is converging, that is, rays meet at a point after reflection, whereas convex mirror is diverging, that is, rays spread outwards after reflection, and rays do not actually meet at a point but appears to be coming or originating from a point. This point is called the focus of a convex mirror. Note that focus of convex mirror lies behind the mirror. The relation R equals twice of f still holds true for convex mirror. After understanding all the terms, we are now in a position to discuss the image formation by the spherical mirrors. An image is formed when there is an intersection of more than one reflected rays. Before we move further, let's understand some important rules that light rays obey. According to rule 1, light rays parallel to the principal axis meet or appear to be coming from the focus of the mirror after reflection. Rule 2 states that light rays that pass through the focus emerge parallel to the principal axis after reflection from the mirror. According to rule 3, a light ray that passes through the center of curvature reflects back or retraces its original path. Rule 4 states that when a light ray is obliquely incident on the pole, the light ray follows the laws of reflection. That is, it reflects along the same angle as the angle of incidence. That is, angle I equals angle R. As per rule 5, light ray normal to the mirror always passes through the center of curvature. These rules are also valid for convex mirror. These rules will be applied to form ray diagrams. Let's begin with the concave mirror. Case 1. When object is placed at infinity. For this case, we cannot actually place an object on the principal axis. Instead, rays are assumed to be coming as parallel to the principal axis. Therefore, by using rule 1, these rays will meet at focus. The point of intersection is where the image is formed. It is clear from the diagram that image is formed, number 1, at focus, number 2, is highly diminished, that is point sized, number 3, is real, that is, it is formed in front of the mirror and can be obtained on a screen. For the next case, we will place the object beyond C, that is center of curvature. This object can be a pencil, penguin or a star, but in ray diagrams, an upright arrow is used. For this case, 3 incident rays are shown. First parallel to the principal axis, second at pole and third at focus. By the application of respective rules, an image is obtained between focus and center of curvature, which is diminished in size and is real and inverted. Next case is when the object is placed at C, that is center of curvature. We again incident the same 3 rays and obtain an image at C, which is of the same size and is real and inverted. Next case is when the object is placed between center of curvature and focus. For this case, image is formed beyond C, which is enlarged, real and inverted. If the object is placed at focus, we see the reflected rays will meet at infinity. The image formed will be highly enlarged, real and inverted. For the last case, the object is placed between pole and focus. In this case, the rays will not meet in front of the mirror but appear to be coming from behind the mirror. The images so formed are called virtual, which can't be obtained on the screen. The image is enlarged and erect. For convex mirror, there are just 2 cases. Case 1 is when the object is placed at infinity, then the rays appear to be coming from the focus behind the mirror. The image is point-sized, virtual and erect. For the second case, the object is placed anywhere between infinity and the pole. we will always obtain an image between pole and focus, which is diminished, virtual, and erect. There are set of sign conventions that must be followed while dealing with the reflection of light by the spherical mirrors. These are: number 1. Always place the object left of the mirror. Number 2. All the distances are measured from the pole, so it acts as origin. For example, we want to know the distance of object AB, so it must be said PA, not AP. Number 3. Distances that are measured to the right of pole are positive, while the distances measured to the left of pole are negative. Number 4. Heights measured above the principal axis are taken as positive, while below the principal axis are taken as negative. This was it for the video. See you in the next one. Thank you for watching.